Hey grade 10s, I hope you guys are doing well and that you enjoyed your April break. Happy to be back with you guys. I'm sorry that everything kind of went back online again, and you have to do this whole transition. However, luckily this isn't the first time that this has happened, so hopefully you guys are all used to what's going on. I just want to state and make a comment that if you guys need any resources in terms of like a electronic device, a laptop, anything like that, just please email me so we can figure out what we can do for you so that you can have the proper equipment to make sure that you're able to succeed throughout the course. I'm sure your other teachers have told you that as well. And I'm just assuming based on how we did completely online last time that most of you guys or all of you guys are good to go. If you have any issues or you just want to talk about kind of what's going on, you can always email me at any point, even if you just want to chit chat or get something off your chest and you want to tell me, always you can email me. So today we're going to continue. It's a little bit of a lighter lesson. The homework itself isn't hard, but there might be quite a bit to do. So you can use kind of this entire period to make sure that you get all of that done. And that if you didn't complete your homework from Thursday and Friday before we went on April break, it is due tonight. So my suggestion to you would be just to get your homework done today so that tomorrow when we kind of come back into our synchronous class that we're ready to go. And I just want to make sure that everyone knows our class tomorrow will be at 1:35 p.m. and it will go until 2:50 p.m. Okay, so a whole 75 minutes. So today's lesson, we're going to be looking at the Bohr Rutherford models of elements. So we're going to be looking at how to draw Bohr Rutherford diagrams. Again, this is a review from grade 9, so hopefully you guys remember how to do this or you've seen it before. So the learning goals for today is by the end of this lesson, you will be able to know how to draw a Bohr Rutherford diagram. So over here, I have a simple image of a Bohr Rutherford diagram. It's showing you that the protons and neutrons are located at the center of the nucleus, and we have our electrons that can be found they're called valence shells, and they surround our nucleus that hold the protons and neutrons. Just to recall, the electrons are negatively charged, protons are positively charged, and neutrons have no charge at all. Okay, so they're chargeless. Atoms are made up of certain things and they both have negative and positive charges, so they cancel each other out. And usually this is why when you're looking at your periodic table that all of our atoms are not charged negatively or positively because the amount of protons that we have is the same to the electrons. Unless we talk about ions, which is something we're going to talk about a little later on. That's when you lose or gain an electron to make the atom become positive or negative, which turns it into an ion. But again, that's something we're going to talk about later. Today, we're focusing about how to actually draw your atoms. So Bohr Rutherford diagrams are drawings of atoms that show the number of protons and electrons in the nucleus and the number of electrons in the energy level, which are known as orbits. So I want to stress to you guys that usually when you're drawing your Bohr Rutherford diagram, most of the time they'll probably be 3 orbits. I mean, you can go more to that, but for example, for today, the most you're going to go to is the 3rd orbit. I want to stress that when you guys draw your first orbit, it only holds 2 electrons, 1 and 2. And you guys will notice that here. So you're only drawing 2 electrons. Once you have more than 2 electrons is when you add your second orbit. Your second orbit can hold 8 electrons, your third orbit holds 8 electrons, and so on. It always holds 8 electrons. So it's just your first orbit that only holds 2 electrons. Okay, then every orbit after your first holds up to 8. I also want to, maybe the next image will be a little bit nicer looking. Yeah, it's a little bit better. There's a lot going on here. We'll kind of explain what's happening. So as always, looking at this yellow box over here is what you're going to see in your periodic table. We have beryllium. The number up here, this is your atomic number. So number of protons that are found, and at the bottom here is your atomic mass, and your atomic mass includes your protons and your neutrons. And you guys can remember that you can figure out the amount of neutrons that are found in this particular atom is you're going to take your atomic mass and you're going to minus it by your number of protons, which would be your atomic number. Okay, and because protons are positive, and we know that this atom is neutral, it's not a positively charged or negatively charged, you know that you have a total of 4 electrons. Okay, so already everything we've already known from before. This number should really be flipped. The 4 should really be on top and the 9 should be at the bottom. Your atomic mass is at the bottom where your atomic number is at the top. So that's kind of a little bit of a mistake in this image here, but that's okay. So when you're drawing your Bohr Rutherford diagrams, the first circle is the nucleus, the number of protons and the number of neutrons are written, and it's showing that the mass of the atom is almost entirely represented of what's inside of the nucleus only. So for beryllium here, you're going to write that we have 4 protons, and you're going to write that we have 5 neutrons. And again, you figured that out because you took your mass and you minus the number of protons. Okay? Then you guys are going to start drawing your energy levels known as valence shells or orbits. So your first one that you have here, you only place 2 electrons in your first orbit. So you're going to place the first one and then the second one. Then, because we still have to include 2 more electrons, since it's, again, positive, proton is positive and there's 4, that means we have to have 4 electrons. So you would put your first 2 in the first valence shell, and then you're going to put your next one in the second orbit. Now, I want to note that it's extremely important that you kind of see here how we have 1 electron at the top here and 1 at the bottom, and how they're not stacked beside each other. And there's a reason for that. It's called the Aufbau principle, and it states that electrons fill the lower energy atomic orbits before filling higher energy ones. You don't have to worry about that. If you go to higher levels in university, you would learn more about that. But I just want to show you guys and explain that it's important that you actually place 1 electron here, 1 at the bottom, and that you're not putting them beside each other. When you start drawing your second orbit and when you start drawing your second valence shell, you're going to do the same things. You're going to add 1 on top, 1 at the bottom. You're not going to stack them right beside each other. Or you could have put like 1 electron here, 1 electron here. You kind of go around the circle, and then once you start having more than 5 electrons that you need to include in the Bohr Rutherford diagram, then you start putting them together as a pair. And I'm going to show you that with an atom that has more electrons found in it. Okay. So here's another example with calcium. You can see again the atomic mass is 40, and if we were to subtract 20 from it, that means we would have 20 neutrons that are found. So then in the center of the nucleus, you're going to put 20 protons and 20 neutrons. If this atom here is neutral and we have 20 protons, how many electrons should you have? So hopefully you guys thought of 20 electrons. It does say it here, and you can count it out here, but hopefully you're kind of understanding how they're related to each other. So again, I just want to note that the first orbit here, you guys can see it's only 2 electrons, and that every other orbit after that, you always make sure there are 8. So once this orbit is full of 8 electrons, which we can see 2, 4, 6, 8, then you're going to start including the other electrons to the next orbit. And once this one's full, 2, 4, 6, 8, then you're going to include another orbit and start adding the electrons there. Okay? So we're going to talk about Lewis diagrams very briefly today, but I'm going to mention it again later on. So Lewis diagrams are a shortcut or an easier way of, I guess you could say, of drawing your atoms. It's a little bit quicker. So we are going to talk about it a little bit more in depth later on, but I'm just going to introduce it to you guys here because we will be using Lewis dot diagrams in grade 10 as well as you will also be seeing Bohr Rutherford diagrams. So when drawing a Lewis diagram, basically you don't see these orbits or these rings that are around the nucleus. You kind of get rid of that. And all you do is you're basically drawing around the element symbol. So Be is the element symbol. And all you're doing is you're drawing the electrons that are found in the valence shell. So what that means is that this outer shell, the shell that's on the outside is called or known as the outer valence shell. And what you're going to do is you're only going to draw the amount of electrons that are found in the outer valence shell. So there's 2 on the outer valence shell for the beryllium. So you're only going to draw 2 electrons in the exact same configuration around that element. So let's say if there was 4 electrons that are found in the outer valence shell, then you would draw 4 electrons here. If there were 7 electrons that were found on the outer valence shell, then you would draw 7 electrons for your Lewis diagram. You wouldn't include the electrons that are found within the inner of the orbit. Hopefully that makes sense. Okay, so this is actually a really nice example here. So again, it's showing you how do you draw with the Lewis dot diagram. So in the center we have here is our element, which is phosphorus. And we can see that we have 1, 2, 3, 4, 5 electrons. So to me, that means that when I look at my Bohr Rutherford diagram, that there should be a total of 5 valence outer electrons. So if I go into count, 1, 2, 3, 4, 5. Basically, it gets rid of drawing all the electrons in the inner orbits or the first few orbits. Okay, hopefully that makes sense. If not, like I said, we're going to go over Lewis dot diagrams again a little later on, and this won't be the last time that you'll be seeing it. So Lewis diagrams are very useful, although it does not show the level of detail as a full Bohr Rutherford diagram. So that's why sometimes it's not used all the time, and that's why sometimes Bohr Rutherford diagrams are preferred. Valence shell is the most outer shell, and valence electrons are the electrons that are found in most outer shells. Okay, so remember, you're only drawing the valence shell, which is the outer shell, or the outer orbit of the Bohr Rutherford diagram that you're drawing. Bonding and chemical reactions result from interactions of valence electrons, so the outer shell, and that's why Lewis dot diagrams are more useful for communication, especially you guys are going to see in grade 10 when we're showing the exchanges or sharing and bonding between different types of atoms and elements. We're going to be using Lewis dot diagrams to show how the electrons jump from one atom to another. We're going to be using kind of this method to do that. So the answers are shown in your PDF file. You will see them there, but I want you guys to try and draw the answers of Bohr Rutherford diagram models on your own, and then you're going to check through the answers. So you're going to do that. Make sure that you practice it. If you do want to try with the Lewis dot diagrams as well, you're more than welcome to do that as well. I can post the answers for that later on. I could do it and just take a picture. So if you want to do it for both Bohr Rutherford and for the Lewis dot diagrams, you can. But for now, you're just required to do the Bohr Rutherford diagrams. So the answers are all there. And then for homework, it's already uploaded on your Google Classroom, Bohr Rutherford diagrams, PDF file, and you guys are also required to do question 4 on page 187 of your textbook. I hope you guys enjoy the rest of the day. I will see you tomorrow at 1:35 p.m.